Today we'll see about the co-channel interference reduction methods and the trunking and grading and all those things. So coming to the co-channel interference reduction methods, interference is major factor affecting the performance of the cellular communication systems. So this identified as the very major factor which affects the performance of the cellular communication systems. The source of interference may consist of a different mobile working in the same or in the neighboring cells which are operating in the same frequency band that may leak energy into the cellular band. Cells that use same set of radio channels are called co-channel cells. Cells that use same set of radio channels are called co-channel cells, and the interference caused by received signals coming from these cells is called co-channel interference. See the differences between the co-channel cells and the co-channel interference. The cells that use same set of radio channels are called co-channel cells, and the interference caused by the received signals coming from these cells is called co-channel interference. If the different cells in the cellular network use different radio channels, then the inter-cell interference should be kept at a minimum level. When the number of mobile users increases, the radio channels available in the system are limited. Then, in order to satisfy this high demand, the radio channels have to be reused in the various cells. That is why, for increasing the capacity, there exist many co-channel cells which may simultaneously serve the large number of the users. And coming to the adjacent channel interference, the signals from neighboring radio channels, also called adjacent channel, leak into the particular channels, thus causing adjacent channel interference. Adjacent channel interference takes place due to inability of mobile phone to separate out the signals of adjacent channels allocated to the neighboring cells. That is, for example, channels of 101 in cell A and 102 in cell B, where both A and D cells were present in the same reuse clusters. The problem of the adjacent cell interference can become more serious if a user transmitting on a channel which is extremely close to a subscriber's receiver channel, while the receiver tries to receive a signal from base station on the desired signal. That is what a filter passband which is being kept on the B channel, the frequency, the far based desired channel, the near based in the adjacent channels. And the core channel, the adjacent channel, and the interference in the mobile, so the designed signal which is being placed in the red, and the signals on the single on the adjacent channel which is being placed with the responses of the filter which is being placed on this particular diagram. And coming to the trunking and grade of service. In a cellular mobile communication, the two major aspects that have been considered with extra care are trunking and grade of service. These aspects are to be planned very well in order to get a better system performance. The grade of service is a standard which is used to determine or which is used to define the performance of the cellular mobile communication system by specifying a desired probability of a mobile user acquiring channel access when a definite number of radio channels are present in the systems. The cellular communication network depends on a trunking system to fit large number of mobile users in a limited radio band. The statistical behavior of the mobile users is being exploited by trunking so that the fixed number of channels can be allocated to the large mobile users. In trunking, large number of the mobile users is being accommodated to share the limited radio signals available in the cell area. And you see, this is what the trunk and the grade servicing, where the access network towards your local exchange and then towards your transit, which is being placed in this particular access networking area. And then how we are improving the coverage and capacity. So while we improve the covering and the capacity in a cellular system, previously we have been seen that the frequency reuse technique in the cellular system allows for almost boundless expansion of geographical area and the number of systems users who could be accommodated. In designing a cellular layout, the two parameters which are of great significance are of this cell radius or on the cluster size n, and we have also seen that the co-channel cell distance d is equal to root of 3n(r). The following of the brief discussion of the design of the trade-off is given as the above two parameters plays a crucial role. The cell radius grants both the geographical area covered by a cell and also the number of subscribers who can be serviced given the subscriber density. It is easy to see that the cell radius must be larger as the possible. This is because every cell requires an investment in the tower, land on which the tower is being placed, and radio transmission equipment, and so a large cell size minimizes the cost per subscriber. Eventually, the cell radius is determined by equipment, determined by the requirement that the adequate signal. And these are all the clusters which is being placed, and the note that however, the cell radius is determined by the trade-off or should be able to large as possible to minimize the cost of the installation per subscriber, but R should be possible, small as be possible, to maximize the number of the customers that the system can accommodate. If the cell's radius or is fixed, then the number of clusters could be maximized by minimizing the size of the cluster n. So we have seen earlier size of the cluster depends on the frequency reuse of the ratio q. Hence, in determining the value of n, another trade-off is inquired in that n must be small to accommodate the large number of subscribers, but it should be sufficiently large so as to minimize the interfacing effect. So this is about the things. Thank you.